This is an audiovisual presentation on matrices and determinants. Matrices and linear transformation. A matrix is a rectangular array of numbers. The members in a matrix are called elements. Now, this is an example of a matrix. A matrix is a rectangular array of numbers, and the members in the matrix are called elements. So the element of this matrix are A, B, C, and D. Now, for the matrix A, B, C, and D, this is called the row. So we have row 1, we have row 2, that is 2 rows. We have column 1 and we have column 2. So it means we have 2 rows and we have 2 columns. So this is a 2 by 2 matrix. That is the name given to this matrix. It's a 2 by 2 matrix. That is the number of rows is 2 and the number of columns is 2. So it's 2 by 2 matrix. Now let's consider this matrix. This 2, we have row 1, row 2, row 3, row 4. So we have 4 rows. Now let's look at the columns. We have column 1, we have column 2, and we have column 3. So this is a 4 by 3 matrix because the number of rows is 4 and the number of columns is 3. So this is a 4 by 3 matrix. Now A equals A11, A12, A21, A22. Now A11 means that the position of the A is in the first row, first column. Now A12 means the first row, second column. A21 means the second row, first column. And A22 means the second row, the second column. So A equals A11, A12, A21, A22 is a 2 by 2 matrix, which implies that we have 2 rows and 2 columns. Now we have B equals 3, 4, 2, 4, 1, 7, 5, 2, 8. This is a 3 by 3 matrix. That is, we have 3 rows and we have 3 columns. Now let's look at some types of matrix. We consider the square matrix. A square matrix is a matrix with the number of rows being equal to the number of columns. When we consider the example of the matrices we have here, A equals 2, 5, 7, 3. We have 2 rows and we have 2 columns. So it's a 2 by 2 matrix. That's a square matrix. Now the matrix B, we have 1 row, 2 row, the third row. Then we have column 1, column 2, column 3. So we have 3 rows, we have 3 columns. So this is a 3 by 3 matrix, and that's the square matrix. We have the null or the 0 matrix. Any matrix with all its entries equal to 0 is what we call a 0 matrix. So example, we have 0, 0, 0, 0. This is a 2 by 2 0 matrix because we have 2 rows and we have 2 columns. We have 2 rows and we have 2 columns. Now this is a 3 by 3 0 matrix because we have 3 rows. We have row 1, row 2, row 3, and we have 3 columns. We have column 1, column 2, column 3. So this is a 3 by 3 0 matrix because all the elements is equal to 0. Now we have the unit or the identity matrix. When you say unit, we mean 1. Now the unit or the identity matrix is a matrix with ones along the diagonal, as you can see. So we have 1 along the diagonal. This is a 2 by 2 unit matrix. And for the 3 by 3 unit matrix, you also have ones along the diagonal as shown. Now let's look at addition and subtraction of matrices. Given the matrices A, B, C, D, and B, E, F, G, H. Now when we say A plus B, it means we are adding the two matrices together. So A plus B will be equal to A plus A, B, C, D plus E, F, G, H. Now how do we add two matrices together? We add the corresponding entries. So the first element is added to the first element here. The second element is added to the second element here. The third element is added to the third element here. And the fourth element is added to the fourth element here. So A plus B will be equal to A plus E, B plus F, C plus G, and D plus H. So that is how we add matrices together. We add the corresponding entries. If A equals 3, 1, 2, 2, and B equals 1, 4, 3, 2, evaluate A plus B. Now A plus B means we are supposed to add the two matrices. So we have 3, 1, 2, 2 plus 1, 4, 3, 2. So we have 3 plus 1, 1 plus 4, 2 plus 3, and 2 plus 2. So 3 plus 1 is 4. 1 plus 4 is 5. 2 plus 3 is 5. And 2 plus 2 is 4. So A plus B is equal to 4, 5, 5, 4. Now we look at subtraction. Subtraction goes the same way the addition goes. If A equals A, B, C, D, and B equals E, F, G, H, if these are two matrices, then A minus B is equal to A, B, C, D minus E, F, G, H. How do we subtract? We have A minus E, we have B minus F, we have C minus G, and we have D minus H. That is how we subtract matrices. Example, the matrices A, B, and C are given by A equals minus 2, 4, 3, minus 1. B equals 5, 3, 0, 1. And C equals minus 1, minus 2, minus 3, 4. Now we have to evaluate A minus B and B minus C. A minus B, B minus C. Now A minus B is equal to matrix A is minus 2, 4, 3, minus 1, minus B, 5, 3, 0, 1. Now how do we subtract? We have minus 2 minus 5, we have 4 minus 3, we have 3 minus 0, we have minus 1 minus 1. Now minus 2 minus 5 is minus 7, and 4 minus 3 is 1. 3 minus 0 is 3. And minus 1 minus 1 is minus 2. That means that A minus B is equal to minus 3, 1, 3, minus 2. Now B minus C equals, we have 5, 3, 0, 1, minus 1, minus 2, minus 3, 4. So let's subtract. We have 5 minus 1. We have 3 minus 2. We have 0 minus 3. And we have 1 minus 4. Now, the constant coefficient of the bracket here is 1. So we have minus 1 times minus 1. That will give us plus 1. So we have 5 plus 1. The same thing is happening here. So we have 3 plus 2. We have 0 plus 3. We have 1 minus 4. And 5 plus 1 is 6. 3 plus 2 is 5. 0 plus 3 is 3. 1 minus 4 is minus 3. So B minus C is equal to 3. B minus C is equal to 6, 5, 3 minus 3. Now let's look at multiplication of a scalar by a matrix. Let K be a scalar and the matrix A be equal to A, B, C, D. When you write Ka, it means that we are multiplying the scalar by the matrix. So Ka will be equal to K times A, B, C, D. And when you are multiplying a scalar by a matrix, the scalar multiplies all the elements. So K times A give us Ka. K times B, KB. K times C, KC. And K times D, KD. So that is how we multiply a scalar by a matrix. The scalar multiplies all the elements. Now, equality of matrices. Given these two matrices, A equals A, B, C, D, and B equals E, F, G, H. If A equals B, only if the matrix A equals the matrix B, then it means that the corresponding entries are the same. That means A equals E, B equals F, C equals G, and D equals H. So for equality of matrices, if A equals B, then you can write that A equals E, B equals F, C equals G, and D equals H. Now let's look at multiplication of matrices. Let's look at multiplication of matrices. Let A be equal to A, B, C, D, and B be equal to E, F, G, H. The two matrices. The product AB of the two matrices is given by now AB equals ABCD times EFGH. Now this is the principle or the idea behind multiplication. If you have two matrices multiplying as shown, the first row multiplies the first column. The first row of the first matrix multiplies the first column of the second matrix. And so A times E plus B times G. The same first row will multiply the second column of the second matrix. So we have A times F plus B times H. Now we are done with the first row, so we come to the second row. So the second row multiplies the first column. So we have C times E plus D times G. Leave a space. Now the same second row multiplies the second column. And so we have C times F plus D times H. Now A times E is AE plus B times G is BG. A times F is AF plus B times H is BH. C times C is CE plus D times G is DG. And C times F is CF plus D times H is DH. So in general, that is how we multiply matrices. Now, let's look at this example. If A equals 2, 4, 1, 5, and B equals 3, 5, 7, 2. Find AB, I, B. Now, AB is equal to 2, 4, 1, 5 times 3, 5, 7, 2. If you remember, the first row multiplies the first column. So we have the first row in the first matrix is multiplying the first column in the second matrix. So 2 times 3 plus 4 times 7. Then we leave a space. 2 times 5 plus 4 times 2. Then we are done with the top. Now we come to the second row. So we have 1 times 3 plus 5 times 7. We have 1 times 5 plus 5 times 2. Now we simplify. 2 times 3 is 6 plus 4 times 7 is 28. 2 times 5 is 10 plus 4 times 2 is 8. 1 times 3 is 3 plus 5 times 7 is 35. 1 times 5 is 5 plus 5 times 2 is 10. Now 6 plus 28 equals 34. 10 plus 8 equals 18. 3 plus 35 equals 38. And 5 plus 10 equals 15. So it means that AB is equal to 34, 18, 38, 15. Now BA. We are multiplying B by A. So the B first before A. So we have 3, 5, 7, 2 and 2, 4, 1, 5. So we are multiplying 3, 5, 7, 2 by 2, 4, 1, 5. Now let's multiply. 3 times 2 plus 5 times 1. 3 times 4 plus 5 times 5. 7 times 2 plus 2 times 1. 7 times 4 plus 2 times 5. That is, the first row multiplies the first column. The same first row will multiply the second column. Then we come to the second row. The second row multiplies the first column. The second row multiplies the second column, and we are done. So I go over 3 times 2 plus 5 times 1. 3 times 4 plus 5 times 5. 7 times 2 plus 2 times 1. 7 times 4 plus 2 times 5. So 3 times 2 is 6 plus 5 times 1 is 5. 3 times 4 is 12 plus 5 times 5 is 25. 7 times 2 is 14 plus 2 times 1 is 2. 7 times 4, 28 plus 2 times 5, 10. Now 6 plus 5 is 11. 12 plus 25, 37. 14 plus 2, 16. And 28 plus 10 is 38. So it means that BA is equal to 11, 37, 16, 38. Now we have multiplication of a 2 by 2 matrix by a column matrix. If the matrix A equals A, B, C, D, and the column matrix V equals XY, then when we write AV, it means that we are multiplying the matrix A by the column matrix V. So AV equals A, B, C, D times XY. A, B, C, D times XY. So AV equals A times X. That is A times X plus B times Y. C times X plus D times Y. Now A times S is AX plus B times Y is BY. C times X is CX plus D times Y is DY. So AV is equal to AX plus BY dx plus dy. Now example, find AV if A equals 2, 3, 1, 2 and V equals 5, 4. So AV will be equal to, the matrix is 2, 3, 1, 2 times 5, 4. This is equal to 2 times 5 plus 3 times 4. 1 times 5 plus 2 times 4. Now 2 times 5 is 10 plus 3 times 4 is 12. 1 times 5 is 5 plus 2 times 4 is 8. So 10 plus 12 is equal to 22 and 5 plus 8 is equal to 13. So AV is equal to 22, 13. Now let's look at how we can find the determinant of a 2 by 2 matrix. The determinant of a 2 by 2 matrix. The determinant of a 2 by 2 matrix. Now let's consider the matrix A equals A, B, C, D. The matrix A equals A, B, C, D. The determinant of A is written as shown. That's the magnitude. The symbol of the magnitude. That is what you use in representing determinants. So if A equals A, B, C, D, then the determinant is equal to the determinant of the element, that is A, B, C, D. Now how do we find the determinant? We multiply the first term. Multiply the first term or the first element by the fourth element. So A times D minus the second element times the third element, that is B times C. Now A times D is AD minus B times C is BC. So that is how we find the determinant. We multiply the first element by the fourth element minus the second element by the third element. Now let's look at this example. If the matrix A equals 2, 1, 3, 4 and B equals 3 minus 2, 6, 5. Find the determinant of A and B. Determinant of A is equal to, that is the representation of determinant, don't forget. Now we multiply the first element by the fourth, so we have 2 times 4 into bracket minus 3 times 1, so we have 3 times 1. Now 2 times 4 is 8 minus 3 times 1 is 3 and 8 minus 3 is equal to 5. That means that the determinant of A is equal to 5. Determinant of B is equal to 3 minus 2, 6, 5. Now we multiply the first element by the fourth element. So we have 3 times 5 minus 6 times minus 2. So 3 times 5 is 15 minus 6 times minus 2 is minus 12. So 15 minus 1 times minus 12 will be 15 plus 12. And this is equal to 27. 15 plus 12 is equal to 27. So that is the determinant of B. Example, solve the following equations. Here you have to solve the following equations, but the symbols we see is a determinant symbol. That will tell you that find the determinant. And in finding the determinant, you solve for the equation. Now, we have determinant of x plus 1, 2, 2x minus 1, 3. So we multiply the first element by the fourth. So we have 3 times x plus 1. That's how come we have 3 into bracket x plus 1 minus 2 times 2x minus 1 is equal to 4. I repeat, we multiply 3 by x plus 1 minus 2 by 2x minus 1. We equate the answer to 4. Now 3 times x is 3x. 3 times 1 is 3. Minus 2 times 2x is minus 4x. Minus 2 times minus 1 is 2. And this is equal to 4. Now 3 plus 2 is equal to 5. And 3x minus 4x is minus x. This is equal to 4. Now we are solving for x. So minus x on the left hand side can be x on the right hand side. And 4 on the right hand side also be minus 4 on the left hand side. So we have 5 minus 4 equals x. And 5 minus 4 equals 1. So 1 equals x can be written as x equals 1. Now B. The determinant of 5x plus 2, 6x minus 3, 4, 3 is equal to 0. So let's find the determinant. It's 3 times 5x plus 2 minus 4 times 6x minus 3 is equal to 0. 3 times 5x is 15x. 3 times 2 is 6. Minus 4 times 6 is minus 24. Minus 4 times 6x is minus 24x. Minus 4 times minus 3 is equal to plus 12. And this is equal to 0. So we have 15x plus 6 minus 24x plus 12 is equal to 0. Now we group the x on the left hand side and the constant on the right hand side. So we have 15x minus 24x is equal to 0 on the right hand side. Plus 6 on the left becomes minus 6. And plus 12 on the left becomes minus 12. So 15x minus 24x equals minus 9x. And this is equal to 0 minus 6 minus 12. And this is equal to minus 18. So we divide both sides by 9. We divide both sides by negative 9. When we divide the left hand side by negative 9, we are left with x. And when we divide the right hand side by negative 9, we have 2. That means that the value of x is equal to 2. Now, we have the Cramer's rule. Given ax plus by equals p and cx plus dy equals q. These are simultaneous linear equations. And we are going to look at how we can use the Cramer's rule in solving simultaneous equations. Take note. From equation 1, coefficient of x is a, coefficient of y is b, and the constant is p. Now, from the second equation, coefficient of x is c, coefficient of y is d, and the constant is q. Now, the coefficient of the variables, the coefficient of x and y are a, b, c, d. So that forms a 2 by 2 matrix. And the variable is xy. This is equal to pq. Now the matrix A equals A, B, C, D. This is called the matrix A. It's A, B, C, D. So the determinant will be equal to determinant of A, B, C, D. Now, look at what is going to happen critically here. AX plus BY equals P and CX plus DY equals Q. Now we know that A is the same as A, B, C, D. That is, A is the matrix A, B, C, D. Now we have to find AX. That is A subscript X. And with the X, what is happening is the second column remains the same. But the first column, that is AC, is replaced by the constant PQ. So AX equals PQ BD. So the determinant of AX will be the determinant of PBQD. I repeat. When you take the coefficient of the X and Y, we have A, B, C, D. And that forms the 2 by 2 matrix. The variable is xy, and this is equal to the constant PQ. If you are finding AX, before that, you know that A is the matrix A, B, C, D. So let's find AX. In finding AX, you maintain BD, as can be seen, but the AC is replaced by the constant PQ. And that's what we have here. So AX is equal to PBQD. So the determinant of AX will be the determinant of PBQD. Now, if you want to find AY, AC, that is the first column, remains the same. But the second column, instead of BD, is replaced by the constant PQ. And so we have PQ. So now AY is equal to APCQ. And the determinant of AY will be equal to the determinant of APCQ. Now, after everything, if you want to find x, x is equal to the determinant of AX over A, determinant of A, and y equals the determinant of AY over the determinant of A, provided the determinant of A is not equal to 0. Provided the determinant of A is not equal to 0. Now, let's look at this example. Use the Cramer's rule to solve 3x minus 4y equals 2, x plus 2y equals 4. Now, given 3x minus 4y equals 2 and x plus 2y equals 4, coefficient of the x and y will be 3 minus 4, 1, 2. And that forms the matrix. So we have 3 minus 4, 1, 2. Multiplying xy is equal to the constant. The constant is 2, 4. Now let A be equal to 3 minus 4, 1, 2. That's A is the matrix. That's the coefficient of the x and y. So A is the matrix 3 minus 4, 1, 2. Now, we know that A is the matrix 3 minus 4, 1, 2. So the determinant of A will be the determinant of 3 minus 4, 1, 2. How do we find the determinant? We multiply the first element by the fourth element. So we have 2 times 3, and that will give us 6. Minus 1 times minus 4 is also minus 4. So 6 minus 4 will give us 10. So the determinant of A is equal to 10. Now, we are now finding the AX. We have 3 minus 4, 1, 2, multiplying xy and giving us 2, 4. If you want to find the AX, take note that the minus 4, 2 remains the same. But because we are finding AX, the 3, 1 is replaced by the constant 2, 4. That is how come we have 2, 4 here. So AX will be equal to, the determinant of AX will be equal to the determinant of 2 minus 4, 4, 2. And how do you find determinant? 2 times 2, that is 4. Minus 4 times minus 4 is also minus 16. So 4 minus 16 will give us 20. Because the coefficient of the bracket here is 1. So we have minus 1 times minus 16. That will give plus 16. So 4 plus 16 will give us 20. That means that the determinant of AX is equal to 20. Now, how do we find the AY? With the AY, the 3, 1, that's the first column, remains the same. But the second column is replaced by the constant 2, 4. So we have 2, 4. So AY is now 3, 2, 1, 4. And we are finding the determinant now. So 4 times 3 is 12. Minus 1 times 2 is 2. Now 12 minus 2 is equal to 10. 12 minus 2 is equal to 10. So the determinant of AY is equal to 10. Now using the Cramer's rule, after our calculation, we have AX, determinant of AX to be 20, determinant of A to be 10, and determinant of AY to be 10. So X equals determinant of AX over determinant of A. And determinant of AX is 20 over determinant of A is 10. The answer is 2. Y equals the determinant of AY over the determinant of A. And the determinant of AY equals 10. And the determinant of A is also equal to 10. And 10 divided by 10 is equal to 1. So it means that the value of X is equal to 2 and the value of Y is equal to 1. This is the end of our presentation on matrices and determinants.